Okay guys, so somebody approached me lately with a question about running an inverter like this maybe on this Victron Battery Protect, I guess that's what they called. Smart Battery Protect. Okay, this one is at 220 amps. And I didn't even think about it before, but they bring up a good question. If you're gonna let this battery protect shut off the inverter, or pretty much control the inverter, does it gonna destroy the Victron Battery Protect? And as I was thinking about it a little bit, I have to say yes, because the inverter will pretty much destroy any switch. Okay, it doesn't have to be just Battery Protect Victron, but any switch, and that's because of the power draw when you connect the inverter. And I'm gonna show you exactly what I mean, but I've been running these inverters here. I got this one, it's a 3000 watt Go Power inverter, and then I have this one which is 1500 watt Go Power inverter hooked up to the system right now, and they've been running without any issues. I am running this one on a big one, and this one which is 100 amps on the smaller one which is 1500 watts. But I didn't have that many actually, how do you say that? That many occasions when this would go below the voltage settings that would have to shut off the inverter. I don't even remember one time that would dip below the settings, which is about 12. I believe I have it set, this one, on 12.6, maybe 12.7 volts, and this one is set 12 volts to shut off. So yeah, I didn't even have probably one occasion to pretty much have the battery protect shut off the inverter and then turn it back on. But it's a good point, so let's take it to the bench. And I will also show you how to correctly wire the inverter to this battery protect without any issues. Alright, let's go to the bench. So what we have here is very simple setup, but first I want to go into that inverter. Inverter. Why is it actually sparking so bad when you first connect the inverter? And it's not even turned on, and there is nothing to plug in. Okay, the inverter is shut off, and this is the wire that I have just temporarily pretty much connect the inverter. This one is not connected to anything, but this has been sitting for about maybe 6 months without use. Okay. So it's completely discharged, and I can show you that there is no voltage on it whatsoever. Zero. Okay, you can go on the battery. You can see 12.48 volts, which is very low, but you know, there's the power here. We got nothing. Okay, zip. Yet now, when I'm going to connect this to the battery, it will spark like crazy. Okay, and that will pretty much, that spark, if you're going to run it through the through the Battery Protect, that's what's going to destroy the Battery Protect. There is no any backfeed or any, I don't know what I have read on the blogs and what I have seen on YouTube videos. No, that's a nonsense. What's going to destroy this Battery Protect is this spark. Alright? This was very small, but it was strong enough to actually melt the wire to the battery point here. It really depends how you touch this thing. Okay, now we might have some power here. Okay, now we have a 12 volts here. You see? Now when we have a 12 volts and it's discharging, when I turn it on, it will actually probably discharge faster. There you go. Now it's discharging much faster. And those are the capacitors inside, okay? So it's going to take some time to discharge it again. But we know about this, right? When you try to connect especially bigger inverter to the power source and you have not even anything plugged in and it's not even turned on, it's going to spark like crazy, right? And that's because the capacitors inside are discharged and they want to suck in the power really fast, okay? That's what happens. And right now it's charged a little bit, but so there's not going to be spark, but it goes back. But anyway, that's what will destroy the Battery Protect after maybe a few use. I don't know. I mean, maybe more than a few. But that spark is actually what is destroying this device. Okay. Now, if you don't like the spark, there's a very easy solution to it. You just get this light bulb, which is a 50 watt low volts light bulb, not LED, just a regular incandescent. And what you can do, you can just, now hold on, let me actually get this in here, and you can see how it's going to be charging. Well, right now it's charged, but let me turn it on. Okay, see now it's going down really fast. So let me shut it off again. Okay, now the capacitors are pretty much discharged. Now if you want to avoid the spark, what you want to do, just take the bulb and pretty much connect the bulb and it will charge without a spark, because the bulb is a resistor that's good enough to prevent the spark. Okay, that's one way to do it, to avoid these sparks. Just a simple light bulb. It will recharge the thing and now there's not going to be any spark. Okay. Now let's go back to the so pretty much what we established here, that the capacitors inside the inverter are discharged, and when you connect it after sitting for a while, which will completely discharge the capacitors, when you first connect it to the battery, it will spark like crazy. And everybody who has the inverter knows this. So I don't want to go any more into that. But let's go into wiring this puppy to the inverter. The way it's not going to destroy your inverter if you want to use this Victron Battery Protect. This one is the 65 amp version. And the beauty of this is that you can use this smallest 65 amp version to run 30,000 watt inverter if you want. Okay, it doesn't matter. because this is not feeding the inverter, this is feeding the switch. And if you have a remote switch, that's even better, because you can just plug this pretty much to the remote switch. And if you don't have a remote switch, you're gonna have to hack it, and it's a very simple, I don't want to get into it. If you don't know how to hack the switch, then maybe you shouldn't even consider doing any of this. Alright, so let me get ready here and we will get into it. Okay, so this is my primitive setup here. Okay, I will try to make it short, as informative as possible. Pretty much 12-volt battery, the Battery Protect, Victron Battery Protect, 65 amps, relay. Now this is a very simple relay, just off and on, 12-volt DC relay. Okay, this is the coil right here, these wires. This is pretty much the contacts. The relay is normally open, so there is no contacts on the relay right now, or in the relay. When I connect this to the battery, there will be a contact, and you will see my meter is actually connected to here, to the contacts, so you will hear the meter. Okay, and you can even hear the contactor clicking. So that's the way, I mean that's the way, this is the way it will work. Okay, the inverter is connected straight to the battery. Okay, wire from plus and minus straight to the inverter. It doesn't go through this Battery Protect. Now, if you have a inverter with a remote switch, which will be the ideal, then you will connect the remote switch to these two terminals right here, and that will turn it on and off. If you don't have it, you would have to hack the switch on the inverter. Up to you. Okay, and this is how it works pretty much. This little puppy, we're gonna get him in the app and set it up for, let's see, I have to refresh it, and that little puppy would be right here actually. Okay, and that will show me that the battery is 12.49, which actually showed me the other one that is 12.4. That one showed me 12.48, but whatever. So the battery is 12.49, and if I want to show you how this works, I'm going to go into settings, and I'm going to set it on a shutdown at let's say 12.45 or 46, 45, whatever, 45. Okay, and the restart, well, I have to change the restart first, obviously, and then do this one, because it's not going to let me do it. There is a certain limit that it will keep distance from each other from turning it on and off. So anyway, don't want to get into it right now. That's not the point. We're gonna get into 12.45. Okay, and restart. Well, okay, this is not gonna happen unless I'm gonna get a charger hook up to it, and I could actually hook up charger. But anyway, let's do restart at let's go as slow as possible. I guess 12.5. Yeah, it's not gonna let me go any lower. Oh, well, maybe. No, 12.55. That would be pretty much the restart and shutdown at 12.45. So there is 0.1 volt distance between on and off. Okay, so we can leave this on so we see the voltage here. If I can get something behind my mobile, something behind and something in front, well, or maybe like a little rubber mat. There you go. I don't know if you can see it, but I hope so. By the way, the beer is very important for this project too, so cheers. Okay, so now I'm gonna get disconnected here. Let me actually restart this puppy because that's gonna shut down on me very soon. So this is the continuity. So right now, while this is beeping, that means that the inverter would be on. Okay, we're gonna put a load on the battery. Okay, I didn't. We're gonna put a load on the battery, which is my 12-volt bulb right here. And we're not going to be able to hear. Actually, no, we're not going to be able to hear anything, but it will shut off in 90 seconds, or maybe even less than that. But the voltage is already down a lot. I don't even have to. Wow, this battery is not actually in a good shape, so that kind of sucks. Only the relay will drain it. I don't even have to drain the battery because the relay will drain it. But we will see after 90 seconds this will shut off, because this will disconnect the relay and the relay will disconnect the inverter. Okay, so that was 90 seconds, or it's supposed to be 90 seconds. And this shut off at 90 seconds, okay? This shut off power to the relay, and the relay shut off the inverter, because this is connected to the remote switch on the inverter, okay? Now, I would have to get a charger, which I can, really fast. With a battery charger, and start recharging the battery this way. Okay, 1, 2, plug it in right here. This way we will see how it's going to turn on, and it's going to reach 12.55. And I don't know why, but my charger is not running because I got it connected the other way. Not very smart, damn it. Okay, now again, there is a delay on this, but we are at 12.65 volts, and that should count down already. I don't know if it's in 90 seconds again to turn it back on, but there you go. Okay, now the inverter would be on, as is the continuity tester through this relay. So I hope I made it fairly understandable. I mean, this obviously will be connected to the minus, which is the inverter wire powering the inverter, but that has nothing to do with this. Alright, so let's go again. Let's shut this nonsense here. How about if we shut it like this? Very simple. Relay connected to minus, the coil, another one connected to power coming out of the Battery Protect. This way the Battery Protect controls only the relay, and then the relay controls the switch and the inverter. You can also, if you're gonna get big relay, you could also power the inverter through the relay, but it really depends how big is the inverter. If it's only 1000 watts, it's going to be probably fine if you're going to get a big relay. But if it's going to be 3000 or 4000, 5000, 6000 watt inverter, it's going to destroy the relay no matter how big relay you're going to get. Okay? Because that spark on a 3000 watt inverter is huge. And I hope I covered everything at this point. Any questions, hit me back, but I don't know. This is pretty much video for dummies. Really, very simple. Cheers.